So basically, Nicole, we are going to study on hydrocarbons. Okay. So I'll just go through this. Okay. So hydrocarbons. So under hydrocarbons, okay, we have two types, okay, of hydrocarbons that we need to learn. Okay, which is going to be alkane and alkene. Now, if I ask you, Nicole, okay, what are hydrocarbons? What is hydrocarbon? Compound that contains?
Only carbon and hydrogen.
Yeah. Okay, compound that contains only carbon and hydrogen. Okay, so please remember this. Yeah. So when it comes to alkane, yeah, please remember alkane, we call it as saturated hydrocarbon because carbon-carbon single bond. Yeah. So they don't have any functional group. Okay. They do not have no functional group. And because under alkene, okay, they have what the functional group is carbon-carbon double bond. Yeah, because of that, okay, this is going to be called as unsaturated hydrocarbon. Now, when it comes to these hydrocarbons, okay, there are a few reactions that we need to learn. Yeah, for together, as together, they have two reactions. Okay, one is going to be cracking. You can read on this. Okay, because if you have long hydrocarbons, okay, it is not so useful. Yeah. So crude oil, okay, when you get crude oil, we need to do certain things. Yeah, which is cracking. You break it down into smaller parts so that you can use them. And after cracking, we do fractional distillation. Yeah, we separate them according to their melting points. And then we are going to actually use them for our industry. Let's say we are going to use it as for cooking gas. Okay, we are going to use it as petrol, diesel, and so on. Okay, that's actually what we do after cracking. Now, the second reaction that we need to learn under for both of them is going to be combustion. So under combustion, okay, we have two types, okay, complete combustion and we have incomplete combustion. Now, what is the difference between complete combustion and incomplete combustion, Nicole? What are the products, yeah, for complete? Carbon dioxide and water. Yeah. So please remember this. Okay. You need to know complete. We have carbon dioxide and water. Incomplete. Okay. We are going to have carbon monoxide and water. Okay. So if you look at it, yeah, if let's say we want to write down equations, okay, for combustion. So for combustion, when we write the equation, okay, let's say, for example, we are going to write for alkane. For example, we know the general formula for alkane, yeah, is going to be CN, okay, H2N plus 2. And for alkene, okay, the general formula for them is going to be CnH2n. So let's say we take one of the example, okay, for alkene, let's say C4, okay, double plus 2. So 8 plus 2 is 10. So let's say for alkene, I'm going to take C4, okay, double, so C4H8. And I'm going to write the equation, yeah? So let's say, for example, C4 H10, okay, when they combust, okay, when they react with oxygen, okay, if it is complete combustion, they are going to give you carbon dioxide and water. The same thing, C4H8, okay, when there is complete combustion, they are going to give you carbon dioxide and water as well. Okay, but if it is incomplete combustion, okay, they are going to give you okay, carbon monoxide and water, CO and H2O, okay, C4H8 plus oxygen to give you CO plus H2O. So what we need to do, okay, we need to actually learn how to balance the equation. So if you have 4, okay, so we just need to put 4 there. Hydrogen, that's 10, okay, so you need to put 5 there. 5 times 2, okay, is going to be 10. but that is going to make, okay, 5 oxygen and 8 oxygen. That's in total 13 oxygen over here. So how do I get 13 oxygen over here? 13 divided by 2. Okay, why? The 2 and 2 will cancel. So when we write the overall equation, we do not want fraction. So you times everything by 2, you will get 2C4 H10, okay, plus 13O2 to give you 8CO2 plus 10 H2O. Yeah, that is going to be the equation, the balance equation for this. Okay. Now, if let's say I'm going to balance this equation for this, yeah, so quickly C4, so I put 4 there. H is 10, so I put 5 here. 5 oxygen, and then 9 oxygen, yeah. So 9 oxygen, 9 over 2, I times everything by 2, so you have 2C4H10 plus 9O2 to give you 8CO plus 10H2O, everything times by 2. Okay, so similar, okay, we just need to balance the same thing here. So 4, I put 4, okay, then I calculate how many oxygen, so I have 8, okay, and then I have, before that, okay, I check whether I balance the hydrogen first. Hydrogen is 8, so I need to put 4. So now, okay, 8 and 4, so 12. So quite simple, just put 6. Okay, balance. Here, 4, hydrogen is 8, so I put 4. 4 plus 4, so 8, I need 4. So I just balance it just like that. Is it okay, Nicole?
Yeah.
Complete combustion done, yeah. So complete and incomplete combustion done. So now, okay, so let's actually go into, okay, what we the next part is going to be, let's go in detail about alkane. Now, for alkane, we are going to learn about a special type of reaction, okay. The special type of reaction that we will learn under alkane is, okay, is called free radical substitution. Okay, free radical substitution. There are no other reaction, yeah. So for alkane, there's free radical substitution, there is cracking, there's combustion, yeah. So alkane will undergo free radical substitution. What are the conditions for free radical substitution? In order to get the free radicals, you must have sunlight, okay, or the presence of UV light. Now, so let's say if I have alkane, okay, so let's say I'm going to demonstrate by using CH4. And if I have CH4 and I'm going to react with Cl2, okay, halogens, okay, free radical substitution happens for halogens, okay. So when they react, okay, the condition must be at the presence of UV light or sunlight, okay. And what will happen? Okay, a substitution reaction will happen. Okay, so if you follow my ink over here, the blue ink over here. So if you have Cl and Cl, okay, so one of these Cl over here, okay, they will replace or substitute this hydrogen. Okay, they will substitute. And okay, they will go there. So I have C, okay, CH, and then the Cl, okay, they will come over here. And this H, okay, they will combine with another Cl. So you are going to have HCl. Okay, that is going to happen. So this is the overall reaction. And do remember, this reaction is very slow, okay, very slow, and will continue. Okay, until when? Okay, it will continue until, okay, all the hydrogen that is here, they are fully replaced by Cl. So it means they will continue the reaction. Okay, so this particular reaction, free radical substitution, okay, they have their own mechanism of the reaction. So the mechanism of the reaction, okay, is going to be separated into three: initiation, propagation, and termination. So if you look at initiation, of course, they happen, okay, because of the presence of UV light. Okay, so what happens? Okay, initially the Cl2, okay, with the presence of UV light or the sunlight, they are going to break, okay, the Cl2 into free radicals or free radicals. Okay, how? Okay, because the Cl, okay, and the Cl, okay, there is going to be what we call as homolytic fission. Okay, homolytic fission is going to create a species, okay, which is going to be a species with one unpaired electron. Okay, one unpaired electron. So this species, okay, is known as free radical. Okay, so this is known as free radical. And it is very, very reactive. Okay, it's very reactive. So this reaction, okay, will happen. The propagation will happen after you get the free radicals. Okay, so under propagation, okay, these free radicals is going to make the reaction to become to propagate, to give you more free radicals, for example. So what happens next is going to be, always remember, under propagation, we are going to have a neutral molecule or something that is normal. Okay, normal, they are going to react with something that is abnormal or something that is going to be reactive. Okay, so it's always like that. Normal react with something that is reactive, and they are going to give you one normal, one reactive. Okay, so it means normal plus reactive to give you normal plus reactive. So how? Okay, let's say we are writing the equation for this, yeah, this first equation, okay, the one that we did earlier. So let's say we have, okay, CH4. Now, CH4 is normal, okay, and the one that is reactive over here is going to be this one, okay, Cl dot, okay. So they are going to give you, okay, what they will give you. So if I put CH4, H, 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 and then I react with this free radical, what happens? Okay, you are going to have a homolytic fission again here. Okay, they will break. Okay, what happens? You are going to have CHHH, that's a free radical. This H free radical will join with this Cl free radical. They will form a bond. So they will give you HCl. So I write down first. They will give you HCl. And they are going to give you something that is reactive, which is going to be CH3 dot. Okay, you can see normal plus reactive to give you reactive and normal. So it's always like that, Nicole. Is that clear, Nicole?
Yeah.
Okay. So for now, there is another step. Okay, we'll continue with another step. So we repeat this step. Repeat with this, okay, CH3. Okay, so if I have CH3 dot, now the next, okay, Nicole, if CH3, it will react with what? Please remember, okay, it is supposed to be normal and reactive, okay? So now, Nicole, can you tell me the CH3 dot, is it normal or reactive? Free radical is always reactive. So this is reactive, yeah?
Okay.
Okay, so that is reactive. Now, what is normal? So it's supposed to be reactive with normal. So the normal is going to be Cl2. Is that okay, Nicole? Reactive. This one normal with reactive. Okay, reactive with normal. Yeah, and what they will do. Okay, you see what will happen. So you have CH, free radical, and then with normal. Okay, what happens? This will break. Okay, and then they are going to have, okay, free radicals, okay, dot and dot. This will come and join over here. So you will have CHHHCl, and this will stay. Okay. So here, if I write it down, it's going to be, you see, CH3Cl, which is a normal. Okay. Plus Cl dot. So you can see normal and reactive. Normal, reactive. Is that okay, Nico?
Yeah.
Okay. Now, so the next step is going to be termination. So termination is any reaction, okay, that you can actually write, like for example, okay, a free radical with free radical. So you get Cl2. Any free radical, let's say for example, CH3 just now, and then you join with this Cl to give you CH3Cl. Okay, the difference is, okay, the free radical join with free radical to give you something that is normal. Yeah, it can be also CH3, okay, with CH3. So it will give you CH3, CH3. This is also possible. Yeah, termination step. Okay, so these are the steps, okay, that you need to know. Okay, let's say now, okay, we try one example. Okay, so for this example, okay, I'm going to use ethane. Okay, let's say for example, I'm going to use ethane, CCH, H, 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 H. Let's make it interesting. Put Cl there. Okay, already have Cl. Yeah, already have Cl. And I am going to react with Br2. And then this happens with UV light or sunlight to give you CH, H, H, C, H, Br come here, Cl is there. So you get HBr. Now, what type of reaction is this, Nico?
Energy.
For this revision, I only did one reaction only for now, yeah? So free radical substitution. Now, maybe because in the class, our class, we are teaching, I'm teaching you halogenal alkane. We just finished halogenal alkanes with you. So some of the students, they might confuse, yeah? Halogenal alkanes, okay, they undergo this nucleophilic substitution reaction. So this is not nucleophilic substitution. Yeah, why? Because with the presence of sunlight, yeah, although it is starting with halogenal alkane, okay, we are going to deal with the reaction that is going to be alkane actually. Yeah, so this is not nucleophilic substitution. It's free radical substitution. Yeah. So anyways, okay, Nicole, so we just use the same method just now. So we have this step initiation, and we have propagation, and we have termination. Okay. So we are going to write the equations, okay, over here. So for initiation, okay, you should know, yeah. So it starts from Br2, okay, with the presence of UV light or sunlight. Okay, they're supposed to give you 2Br dot. Okay, so free radical is going to be formed. Okay, so what kind of fission is this, Nico?
Homolytic.
Yes. So this is homolytic fission. Yeah. So homolytic fission will create, okay, the free radicals. Okay. So what is free radical? Free radical is a species, okay, with one unpaired electron. Okay, one unpaired electron. Now, so now, okay, under propagation, I already teach you, okay, it must be normal, okay, with reactive. Okay, in this case, the reactive is your free radical, yeah. So the normal, this is the normal, okay. And I don't want to write displayed formula, okay. What I write, I am going to write CH3, okay, this is CH3, and then CH2, and then Cl. Okay, this is normal. What is reactive? This one, the free radical, Br dot is reactive. Okay, what will happen? Okay, do remember. First, okay, I'm not going to rewrite everything again. So you have the free radical come over here. This will be broken. So HBr will be formed. So you get HBr. Okay, so and then, okay, this will leave this part, okay, this entire thing to be left with free radicals, okay. So they will have one dot over here, okay. So how do we write it down? So it's going to be CH3, CH, Cl. You can put the dot here, okay, C for this C, okay. So I can put plus HBr. I can just bring it closer. Is that okay, Nico?
Yeah.
Okay. The next step, normal and reactive, yes. So this is the reactive part, okay, from the product CH3, C dot HCl, the previous one, yeah, the product. They are reactive, must be with normal. What is normal? Br2. And what happened now? The Br, okay, if you react with Br2, for example, now Br2, the Br will go there. Okay, one of the Br will go there, okay, to here. And then remaining Br will be Br dot, yeah. So I'll erase here. So what happens? Okay, you are going to have CH3, CHClBr. Okay, what is CHClBr? So basically you have CH3, CH, okay, ClBr. Okay, left with Br free radical. So you can see normal plus reactive, okay, to give you reactive and normal. Okay, when you look at down the second step, reactive plus normal to give you normal and reactive. So it must be always like that. Okay, so we already reached this part, done. So termination Br dot plus Br dot to give you Br2. You can also have CH3, C dot HCl, from where I get it from here, plus Br dot to give you the CH3, CHLBr. Can I understand, Nico?
Yeah.
Okay. These are the steps, okay? These are the steps, okay, for free radical substitution, okay? So this is alkene, okay, alkene. Now, the next part, okay, that we need to go is going to be alkene, okay, alkene. Now, alkene is very interesting because they are known as unsaturated hydrocarbon. So unsaturated hydrocarbon means, okay, because the presence of the carbon-carbon double bond, okay, it is going to make, okay, this alkene, they are kind of reactive, yeah, because of the presence of the carbon-carbon double bond. So they can undergo this addition reaction. And to be exact, what kind of addition reaction? They will undergo electrophilic addition reaction. So this is only one of the reaction, okay? Only one of the reaction that alkene will undergo, okay? But Alkene will also undergo another reaction, which is going to be oxidation. Okay, we will learn oxidation. Okay, oxidation can be two. Okay, they can react with KMnO4 acidify. Okay, and then it can be coal and dilute KMnO4, or okay, it can be also oxidation with KMnO4, potassium manganate, acidified, but with a more extreme condition, okay, which is going to be hot and concentrated KMnO4. And then number 3 is going to be addition polymerization. So let's actually look one by one, yeah? So number 1 is going to be electrophilic addition. Now, before we go into this electrophilic addition, it is important to find out what is the meaning of electrophile. Yeah. Therefore, okay, electrophile. Okay, let's use Cl as an example. So Cl and Cl, if you do homolytic fission in the previous just now alkane, when you do homolytic fission, you are going to get Cl dot and another Cl dot. These are known as free radicals. Okay, a species with one unpaired electron. Yeah, so this happens when you do homolytic fission. Now, apart from homolytic fission, you can also have what we call as heterolytic fission. So if you have Cl and Cl, heterolytic fission, they will break here. Okay, so it is going to give you Cl, not enough electrons, so they become positive. And then you have Cl2 electrons, they will become negative. Yeah, and one of them, yeah, so this is heterolytic fission. So one of them is going to become electrophile, another one is going to become nucleophile. Okay, which one will become electrophile? Positive charge, they like negative charge. So they love electron because electron is negatively charged. So electron, so this is going to be electrophile. And this is negative charge. They love something that is positive. So they are going to be loving positive. So positive generally in the nucleus. So they are going to be nucleophile. Okay. So how do we define them? Okay, when we define them, electrophile, we define them as electron, okay, deficient species. Okay, not enough electron. Okay, electron deficient species. So, nucleophile we define as, okay, a species with lone pair of electron. Okay, lone pair of electron. So do remember, nucleophile not necessarily must be negatively charged. Okay, so they as long that they have lone pair of electron, they can be nucleophile. So electron loving. Okay, so electrophile. Positive loving or nucleus loving. So they become nucleophile. So we have homolytic fission and heterolytic fission. So the one that we are going to focus on today is going to be under the electrophilic addition. Is this one? Yeah, electrophile. Yeah. So under electrophilic addition, okay, we have few reactions. Okay, there are total 4 reactions that we need to know. One is going to be carbon-carbon double bond with H2. Hydrogenation. We have second, okay, they will react with X2, which is the halogen. Yeah, X is going to be Cl, Br, or I. Okay, halogenation. Or we can have carbon-carbon double bond with HX, hydrogen halide. Okay, X can be again Cl, Br, or I. And then this is going to be reacting with steam. Okay, steam. So the condition over here, okay, each of them, they have conditions. Okay, we'll go through one by one now, the condition. Okay, so Nicole, do you know anything about their conditions? Don't remember, yeah? You must know all this, yeah?
330 Celsius.
Yeah, okay. So hydrogen, okay, is going to be nickel with platinum catalyst, yeah. Nickel and platinum catalyst at 140 degrees Celsius, yeah. So the double bond is going to be broken. So I will not write all the other hydrogen. I'll just write this hydrogen, yeah. So they are going to give you alkene become alkane, yeah. And then this reaction, the second reaction, they are going to be happening at concentrated condition and room temperature. Okay, room temperature. And they are going to give you the X and X. Yeah, so the X will come here, the X will come here. And then same, okay, this one I can just copy. Okay, concentrated and room temperature also. And then they will give you C, C, H, and X. This one, okay, later we will discuss. There is something what we call as Markovnikov addition or Markovnikov rule. Okay. Now, for this steam, yeah, must be hot, yeah. But in your syllabus, okay, concentrated phosphoric acid, 330 degrees Celsius, 6 megapascal. Okay, but in your syllabus, when I check, they just say steam concentrated phosphoric acid. Yeah, they didn't mention about 330 degrees Celsius and 6 megapascal. Okay, but yeah, concentrated phosphoric acid and steam must be there. Steam basically is just telling that, okay, the water is going to be heated at high temperature. So what happened? You are going to get C double bond will be broken. You have H and OH. Okay, so alcohol will be formed. Okay, so all these are electrophilic addition. Now, what we need to know, okay, apart from this Markovnikov rule, okay, so I will actually put it over here. Apart from this Markovnikov rule, we need to know the mechanism of the reaction, okay, how, okay, this mechanism, okay, you can show by using curly arrow diagram. So we need to know how to show. And according to the syllabus, okay, they want you to show one, okay, they want you to show the simplest one, okay, so C and C with BR and BR, okay, and they also want you to show, okay, for C, propene, okay, with HBr. Okay, and I will teach you how to actually draw the curly arrow diagram now. Okay, so here what happens, okay, if you have, okay, alkene, okay, with halogen. Now halogen, Br and Br, they are non-polar. Okay, they are non-polar. So generally there is no delta plus and delta minus. But okay, when the Br and Br, when they come closer, okay, when they come closer to the double bond, what happens? Okay, because the double bond, the pi bond contains a lot of electron. So electron and electron will repel. So please remember, when I say repel, the electron will always move from the bond to the Br one side. Yeah, so from the bond to Br, not from Br to Br, from the bond to Br. When the electron is moving there, this is going to become delta negative. and this is going to become delta positive. That is the two things that you write. Yeah. So one, you show from the bond, it go there. Okay. Second, you write, okay, delta negative, delta plus. Okay, that's the second part. The third part is going to be from here. Okay, there is a lot of electron here. Okay, from this bond to the Br, which is going to be the delta plus. Okay, so what happens? Okay, the Br, okay, the electron will go to Br, and the double bond now is going to be broken. So double bond is broken. Because the electron went to Br, this Br will go in. Okay, they will go in. So what happened to the another Br? Because the electron went towards this Br, so all the electron, the two electrons that exist within the bond here, they go there. Okay, and you can see this is already, okay, heterolytic fission is happening. Yeah, just now I told you what is heterolytic fission. Yeah, you can see. Okay, they break. Okay, so two electrons go to one side will become positive. So you can see in this case, which one is going to become positive? This is going to become positive. Okay, and then, okay, what happens next? Okay, this electron, okay, you see lone pair of electron is attracted to positive. So the Br minus over here is actually the nucleophile. Okay, so the nucleophile will attack the positive. So you are going to get, okay, C, C, Br, and Br. Done. Yeah. So of course, the rest you can fill up, okay, by writing the hydrogen in. Is that clear, Nicole?
Yeah.
Okay. Now, so if I put it over here, what else? Okay, you write the third step. The third step is from the double bond, it goes to delta plus. Okay, and then number 4, what you need to write? Okay, you need to write the from the positive, the carbocation, and then the nucleophile will go to the carbocation. Okay, and then number 5, you need to write the product properly. So therefore, total mark for this is going to be total going to be 5 marks maximum. Okay, 5 marks maximum. So now, okay, let's try. Okay, with this. Okay, but maybe we'll try another one more example. Okay, so one more time, yeah. So just now we try with Br and Br. Okay, let's say this is additional, yeah, Nicole. So this is additional. Okay, so let's actually try to show that with steam. Okay, remember, just now I told you there are 4 reactions. Okay, H2, X2, HX, and HOH. Yeah. So let's actually try, okay, with steam. Yeah. So this one, even in the class, I don't actually discuss. Yeah. So let's say, okay, what happens here? Okay, generally, okay, the O is more electronegative than hydrogen, so the electron will go here. No need to come near to carbon-carbon double bond, so they will become delta negative. This is delta positive. Okay, next is, okay, the next step is this double bond, they will go towards this H or delta plus. Okay, and what happens? The double bond is going to be broken. The H will come, and this is going to be positive, and then left with OH minus. Okay. So if you want to show the lone pair, it's okay. You can show the lone pair. Now, so the plus, okay, I think no need to put the plus so that to avoid confusion. So the OH, okay, they are going to come to this plus, making CCHOH. And the last part is just to put all the hydrogen in. Is that clear, Nico?
Yeah.
Okay. Okay. Now, okay, let's actually continue to propene. Now, if I have propene and I'm going to react with, especially with H, okay, let's say HCl, for example. Okay, there are two possibilities. Okay, you can have, okay, the double bond to be broken, and then the double bond can come here and come here once they broken, and then you have also the double bond can be broken, and then, okay, what happens here is the H, okay, they can come here, and then the Cl they go here. That's one of the possibility. Another possibility is the Cl go here and the H end up here. They are different isomer actually. Yeah. So if you look at it, okay, if I put all the hydrogen in, okay, and then I try to name them, okay, hydrogen, hydrogen, hydrogen. So this is halogenalkane. So you can see this is 3 carbon. So this 3 carbon means it's propane. Okay, propane. At carbon number 2, there's chloro group. Okay, so this is called 2-chloropropane. This is also, okay, propane. And at carbon number 1, okay, there's 1 chloro. So 1-chloropropane. So there are two different isomer. Yeah. So there are two different things actually. Yeah. So we want to find out which one is going to be the major product and which one is going to be the minor product. In order to understand about this, okay, we need to go one step before. Yeah. What is the one step before? Okay. So let's say, for example, okay, when I get this, okay, if I copy and paste it here, okay, one step before means we erase this part. Okay, the before you get the Cl in, okay, it used to be, okay, positive. Okay, it used to be positive, and the Cl was standing by before going in. Yep. And then we do the same thing over here. Okay, you copy, okay, and then I paste it here. And okay, let's say one step before that Cl came in, this used to be positive, Cl was standing by over here too before it comes. Yeah. So if you look over here, okay, we can actually identify, okay, this carbon, okay, with the positive charge, okay, and this carbon is with the positive charge. And the carbon that I put over there, okay, that is actually the carbon carbon cation. Yeah, so they call it carbocation. Yeah, so that carbon, okay, the blue carbon that I put over there, it has one R group attached to it, and it has another R group attached to it. Okay, so there are two R groups. We call it as secondary carbocation. If you look over here, this carbon, they only have one big R group attached to it. Okay, so this is called primary carbocation. Now, always remember, okay, tertiary carbocation, okay, is more stable than secondary carbocation, and secondary carbocation is more stable compared to primary carbocation. Why is that? Okay, this is what we call as the R group, okay, or the alkyl group, okay, is going to give you, okay, what we call as inductive effect. So this inductive effect, okay, they are going to stabilize, okay, the formation, okay, stabilize the carbocation. So if the carbocation is going to be stabilized, they are going to be formed more. So if you look over here, the second carbocation is more stabilized compared to primary carbocation. Why? Because more R group will give you more inductive effect that will make that positive charge or the carbocation more stabilized. So this is more stable. Okay, this is less stable. So therefore, okay, this is going to be our major product. This is going to be our minor product. The major product is, okay, now you can tell CH3, okay, and then the Cl comes here, H, and then you have CH3. So this is going to be the major product in comparison to having the Cl to come here. Now, of course, this is too difficult. Yeah, we need to do a lot of stuff, then come into that. What is the easiest way of doing this? Yeah, of course, there is the easiest way to do. So if you have C double bond C3, and then I am going to react with HCl, okay? So always remember, okay, this concept rich becomes richer. So this applies to hydrogen. So hydrogen, okay, will always go to the carbon that has the most hydrogen attached to it. Yeah. How? Okay, you complete this first. Hydrogen, 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 hydrogen. Now the trick is you need to see, yeah, this is carbon-carbon double bond. Okay, we are talking about this carbon or this carbon. Now, this carbon has two hydrogen, okay, two hydrogen. But this carbon only has one hydrogen. You can ask me, oh, there's more hydrogen. No, they are not directly attached to this carbon. Okay, so there's only one hydrogen over here. Therefore, this hydrogen, they will go here. Okay, it means that you are going to have CH, H, H. Okay, and then you have CH, CH3, and you will get the positive carbocation, and then the Cl will come here. So you can see that this will be the major product. So you compare, let's compare. The Cl in the middle is the major. Is that true? You can see it's true. Okay, so it means that, okay, you can actually identify. But okay, if you want to explain, they say why. You say rich becomes richer. Why? Okay, because the explanation is, okay, it forms CH3. Okay, you need to still go before the Cl, you put plus. Okay, it forms this carbocation, which is more stable. Okay, which is more stable because it has two, okay, R groups or alkyl groups to give the inductive effect. Compared to, if you want to compare, if the plus over there, compared to one alkyl group in CH plus. Yeah, I think this one may be too long already. Yeah, maybe you get confused. It's okay. Okay. But okay, the idea is, okay, if they ask you to explain, then we have to use this to explain. Okay, the idea is generally why we have this formation of major product. Okay, generally because it has, okay, 1 and 2, okay, two alkyl group that will give you the inductive effect, okay, that will make the carbocation more stable compared to the other. Yeah, so that is the reason. Yeah, you can refer to this if you are not sure. Is that okay, Nicole?
Yeah.
Okay. Now, okay, let's actually try, okay, the curly arrow diagram. Okay, let's say, for example, now we are going to do the same thing. Yes, C double bond C. Let's try something else. Yeah, so maybe I'll put Cl here, Cl here, and then I put Cl here, and then hydrogen. Cl, H. Okay. Maybe it is C, Cl, 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 Cl. Let's say I am going to react with HCl. And I'm asking you, yeah, so what is the major product? Yeah, what is the major product? So, Nicole, can you identify where the hydrogen will come in? HCl. Will it go at position 1 or position 2?
1.
Position 1, because there is one hydrogen. Position 2, no hydrogen at all. Rich becomes richer. So hydrogen, okay, will go here. Hydrogen will go here. Okay, it will be broken. Cl, okay, Cl, Cl, Cl. This Cl will come in here. Yeah, this is the major product. Now, if they ask you to explain, how do you explain? So you have to go before. Yeah, how to go before? Cl, CH, H, C, Cl. Before that is plus. Cl was here. Okay, so before that, what happens? Okay, you have total of 1 and 2. Okay, so it has 2 alkyl groups that will give the inductive effect to stabilize the carbocation. Which carbocation? You can write down this carbocation. Okay, compared to, okay, if the Cl goes to the left, then CHCl plus CCl H CCl Cl. Okay, so this is the explanation. Okay, now what I want to do now is I want to write down, okay, the mechanism of the reaction. Okay, let's actually focus on the mechanism. CHCl, double bond CCl, CCl, Cl, Cl. And then I have HCl. Okay, do remember HCl. You do not need to come and approach the double bond to make it to become polar. Okay, why? Because the bond itself is already polar. Okay, the molecule itself is already polar. No need to go near to the electron. The electron repel. No need. Okay, they will become delta negative, delta plus. Okay, what will happen? From the double bond, okay, it will go to the plus, delta plus, or it can go to the hydrogen. Okay, still the same. Okay, it goes to the hydrogen. And then, okay, what happens? The double bond is broken, so it will be bonded to H. Now, do remember the H will go to the carbon that has the more H. So CH, Cl, this will become, this will become, the hydrogen will go there, okay? And then this Cl, this will become plus C, Cl, Cl, Cl. And there is Cl dot minus, okay? Or maybe we can just write Cl dot minus. Okay, so then this will go here. So next will be CH Cl, H, C, Cl, Cl, C, Cl, Cl, and Cl. Yeah. So this is going to be our major product. Okay. Is that okay, Nicole?
Yeah.
Okay. Maybe the question is a bit more difficult. Okay. But if I make it simple, okay, according to our syllabus, okay, the simple one is like this. Okay. They want you to know related to HBr, for example. So what happened? This one will become delta negative, delta positive. So the double bond will go to the delta positive. Okay. So we have hydrogen, one hydrogen only. So hydrogen will go to this carbon. So I have CH, H, hydrogen go there. C, this will become plus H, and then C. And the Br, okay, the dot minus, okay, if you want to remove the plus also can. This will go here. So this is going to make H, 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 CBr, HC, and then the rest you just fill up the hydrogen. Okay, done. So what is the name of this? Okay, if they ask you to name this, okay, what is this name? This is going to be 3 carbon, so propane. Okay, 3 carbon, propane, longest carbon chain. Bromine is bromo at position number 2. So this is going to be 2-bromopropane. Now, my question to you over here is, okay, these 2-bromopropane, okay, do they have chiral center or chiral carbon? Nicole, do you know what is chiral carbon?
Mm,
Okay, chiral carbon is, okay, the carbon that contains 4 different groups. Yeah. So if you look over here, do they have 4 different groups? H, same group, cannot. Okay, this is not chiral center or chiral carbon. And then this carbon, okay, you see this carbon, one group, another group, but this is also CH3 and this is also CH3. So cannot as well. Okay, so that is not possible. Okay. Okay, now let's actually look at this carbon. This carbon also got 3. Okay, cannot, must be all different. So these do not have chiral center. If they don't have chiral center means they do not have optical isomerism. Okay, they don't have optical isomerism. Now, let's actually have a look at this carbon. Okay, so let's say we have like this. H, and then CH, H, CH, H, H, Cl, Cl, H, and H. Okay. So, Nicole, you tell me whether they have chiral carbon or not. Yeah. How about this carbon? Do they have chiral center?
no.
No, because why? They have hydrogen and hydrogen. Cannot. Yeah, must be 4 different groups. So this one, no. How about this carbon? Okay, you check. This is different. This is different. This is different. And this is different. Okay. This is a chiral center. Okay. Now,
Okay.
how about, okay, hold on. How about, okay, this carbon. Okay. If I look at this carbon, cannot. Hydrogen and hydrogen cannot. This carbon also cannot. Hydrogen, hydrogen, hydrogen. There are 3 same groups, cannot. Okay, so now if you have a chiral center, what we can do is to draw stereoisomer. Yeah, So the stereoisomer is going to be the optical isomerism. So what we do, we need to simplify them. Yeah, so you have carbon. So I just need to put carbon. And then you have hydrogen. Make sure you put the one bond like that for hydrogen. This one, you can simplify this entire group by writing CH2Cl. Okay, CH2Cl. So what we do, okay, another one bond like this, okay, and then you just write down CH2Cl. And for this, okay, you just need to put like this, okay, coming out. So that is going to be Cl. And there is going to be the one that is going behind. So that one, okay, you can actually draw like basically like this, okay, and then you can use the eraser to okay, so you erase. Okay, something like this. Yeah. So you have okay this. So what we need to do, we need to draw another, okay, which is going to be the optical isomer. Okay, so when we draw that, okay, similar, okay, we put the carbon, you put the hydrogen, okay, so it's a mirror image. So this one, okay, they will go this side, CH2Cl. And then this one you draw like this, okay, it's going to be Cl, okay. And then for this one, okay, this one you can actually use the eraser again. Okay, so I just put like this, okay. So for this one, okay, this one just now I didn't put, okay, which is CH2, C2H5, yeah, C2H5. So this is going to be C2H5. And I'll just bring this a bit here. Then I will write C2H5. Okay, Nico?
Yeah.
Okay, so this is going to be the optical isomerism. Yeah. If they ask you to show, because it can be related also. Yeah, if they ask. Okay. So again, coming back to our lesson, yeah. So again, the electrophilic addition is already done. Okay. So now, okay, left with okay, this oxidation and addition polymerization. So I'll just quickly go for oxidation. Now for oxidation, as I told you, there are two. Yeah, one, the easy part, which is going to be if you're using coal, okay, and dilute, okay, KMnO4. Do remember KMnO4, the acidified, the color change. If there is a reaction, the color change is going to be purple, will become decolorized. Okay, purple will become decolorized. Okay, and then we have another condition, hot concentrated. Hot concentrated KMnO4 acidified. Now for cold and dilute, very easy. Yeah, so it's going to be C double bond C. And then when you oxidize, what will happen? The double bond is going to be broken, and then you put the OH and OH. That's it. Okay, so this is called diol. Okay, so if you put all the hydrogen in, okay, so they will look like this. So a diol will be formed. Okay, so this one will give you this. But the difficult part is to when we are looking into hot and concentrated. For hot and concentrated, okay, so there are three conditions, yeah, three ways where it can happen. Let's say if you have the carbon-carbon double bond like this, we can also have carbon-carbon. Let's say, for example, there is CH3, there's hydrogen, let's say C2H5, and there is another hydrogen. We also have another situation when you have maybe CH3, C2H5, maybe we have CH3 and then CH3. Now, for all these three conditions, okay, if you look at it, we always need to put, okay, something in the middle, yeah, near to the double bond. You just put, okay, when we oxidize, it's always like that. So we break them, yeah. So except for the carbon, if you look at the left, if you have carbon bonded to hydrogen and hydrogen, it's quite simple. The product of oxidation, okay, is going to be, for carbon, is going to be carbon dioxide. For hydrogen, the product of oxidation is water. So that's going to be on the left. On the right, it's still going to be carbon and hydrogen and hydrogen. So it's going to be carbon dioxide and water. Quite simple. So if you have carbon and hydrogen, yeah, carbon dioxide and water. Now, if you look over here, for this, okay, when you break, you get C double bond, okay, and then just write down the same CH3H. So C double bond, C2H5, and H. What you need to do, put the O. Put the O. Okay, oxidation. Next, whenever you see that carbon has one hydrogen, okay, to be simple, yeah, put another O. There's one hydrogen here, put another O. So the final product is, okay, it's quite difficult to see like this. C double bond O, you put over here. OH, you put here. CH3, you put over here. So this is going to be a carboxylic acid. Yeah. C double bond O, OH, C2H5. There are two types of carboxylic acid that is going to be formed. So plus. And just make it far a bit. And this one, make it somewhere there. Okay. Now, for this one, do the same. C double bond, CH3, CH3. C double bond, CH3, C2H5. Whenever you have this, very simple, put the O here. There's no hydrogen, leave it. Put the O here, there's no hydrogen, leave it. So the final product, okay, quite simple. Just take this one. You just put it like this. Okay, but it doesn't look so nice. So maybe I'll just rewrite it. Okay, C double bond O, that's CH3, that's CH3. And then this one also, C double bond O, that's CH3, and then C2H5. So that's 2. Is that okay, Nico?
Yeah.
Okay, I'll give you one example. Okay, how if let's say we are using, yeah, so let's say for example, example 1. And then we have example 2. So let's say I'm going to have this C double bond C. I have hydrogen, I have CH, H, another CH, H, H. I have CH, H here. I have CH, H. Example 2 is I have C double bond C, H, H. And I have maybe CH3 and H. Okay. So now, okay, we want to do this. I think the easiest one is example 2. You put this, okay, Nico, on the left, what will you get? Hydrogen, hydrogen, carbon. Carbon dioxide, water. Okay? Yeah. Okay, Nicole?
Okay.
All right. So here you have C double bond, CH3H. Now, what did I tell you to do? First, you put, what should I put? You put the O. Okay. Next, what you should do? You check whether there is hydrogen. If there is hydrogen, what do? You put O here. Okay. So we can rewrite this C double bond O, OH, and CH3. So it's easier to see this way. It's the same actually. And we can easily identify this as carboxylic acid. So example 2 has how many products? They have carbon dioxide, they have water, and they have also this carboxylic acid. Okay. Now, let's look at example 1. What should I do first, Nico? Put this.
Carbon.
Okay. Then group them. There's hydrogen. This is R group. Okay. So what do I need to do? You put C double bond hydrogen. Quite difficult to rewrite this again. You can just write it as C2H5. C2H5, easier. Now, what do I need to do? You put O here. And there's another one that you need to do, Nico. What to do? When you see H, what do you need to do?
O.
The O, yeah. So you can rewrite this C double bond O, OH, C2H5, the same. Okay. Next, group them. This is CH3. This is C2H5. So C double bond CH3 C2H5. What do you need to do first? You put the O. Can you see any hydrogen? There's nothing. Yeah. So done. That's it. Okay. You rewrite it again. You put C double bond O here, C2H5, CH3. Okay. So what is the product? For example, 1, okay, there are 2 products. Okay. This and this. This is carboxylic acid. And this is ketone. Okay?
Okay.
We try example 3, which is more difficult. For example 3, you have C double bond C, and then you have another C double bond C. You have hydrogen, you have CH3, you have hydrogen, you have hydrogen. Sorry, cannot have more than 4. So you have C hydrogen, hydrogen, you have CH3, and then you have hydrogen. Okay, maybe make it CH3, you have CH3 here. Okay, this is more difficult. Okay, what we do, put one line here, put one line here. then group them. This is CH3, this is CH3, so C double bond, CH3, CH3. Nicole, what do I do?
Add O.
Yeah, that's it. Then you have, can you see hydrogen? There's no hydrogen. Just leave it as it is. Yeah. Now, here, you have C double bond and then hydrogen CH3. So, Nicole, what should I do?
Add O.
Add O and check for hydrogen. Then there is hydrogen, you put O there. Okay, done. Now, how about the one in the middle? This one, we have to do extra work, yeah? So the one in the middle, I will rewrite again, C double bond, CH3, CH, H, CH double bond. Let's look at it from here, this part. When I have this double bond, I group first. This is one R group. This entire thing is one R group. Okay, so if it is like that, put the O. Okay, put the O. Leave the CH3 and then leave the entire thing. Yeah, so I'll just put. So there is no issues. Okay, let me erase this part. Okay, now look at the right hand side. The right hand side, okay, is going to be, again, you see here, they have one hydrogen. This entire thing is going to be one R group. Okay, so first what I do, I put the O. When I put the O, I notice there is one hydrogen over here. Okay, and then there is R. So Nicole, what should I do when I see there is one hydrogen there?
Add O.
O, correct. So that's the answer. Yeah. So it means that, okay, if I rewrite this, okay, normally they like to put the carbon double bond O at the top. Okay, so carbon double bond at the top. The OH, you bring it here. Hydrogen. So the CH3, you bring it here. So this will be the answer. Yeah, I just put it in the middle. It's smaller. So there are total of, okay, 3 different types of product for oxidation. So do remember, this is going to be with hot concentrated KMnO4. Okay, acidified. So now, okay, the last one, okay, I'm just going to teach you about addition polymerization. For polymerization, okay, before I go into this addition polymerization, since we are talking about carbon-carbon double bond, okay, please remember stereoisomerism. Just now I teach you about optical isomerism. Okay, but there is another stereoisomerism which we call it as geometrical isomerism, which is cis and trans. Now, this cis and trans, okay, they can exhibit as long as there is the carbon attached to the carbon-carbon double bond is having 2 different groups, okay, A and B. So if you have A and B, they can have cis and trans, okay, or geometrical isomerism. If you have carbon-carbon double bond and then they have A and A, or they have B and B, because they have the same groups attached to this carbon, same groups attached to this carbon, no cis and trans isomer, or no geometrical isomer. So is that clear, Nicole?
Yeah.
Okay, now let's say I want to ask you, okay, example number 1. See whether this, okay, has cis and trans. H, 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 Cl, H. Okay. Does this example one has cis and trans? Nicole? I guide you also, yeah? You see this carbon, and this is the carbon, yeah? The double bond, at the double bond. This has Cl, one group. This is different group. So fine. On the left is fine. On the right, this is one group, and this is one group. So fine also. They do have cis and trans. And if you look over here, if I put them like this, C double bond C, the H, if I put the H over here, and then the H, this side, I put it like this, and this one is C2H5, okay? So let's say I put C2H5 here, and then I put Cl here. This is because they have the two same groups at one side, like sisters, okay? They are called cis, okay? So they are side by side like sisters, so cis isomer. But if you have the H, they put H here, they put the H here, C2H5, and then you have Cl here, because they have H here and H here across, this is going to be trans. Okay, so this is going to be cis and trans. Okay?
Okay.
All right. So not necessarily must be having pair, yeah? So because most of the time we have like this. They will show that CH3, CH3, then Cl, Cl, like pair. Yeah, of course, if you have pair, okay, as long you have the pair like CH3, CH3, Cl, Cl, it's okay, fine. Yeah, this is common. Yeah, this is going to be trans. This is cis. Why? You can see Cl across, Cl at the same side. Okay, okay, common. Yeah, trans and cis. Okay, but when we name them, this one a lot of students don't know. When you name them, okay, they follow trans. So it means when you name them, you follow the longest carbon chain. This is the longest carbon chain. So it's 4 carbons. So but the double bond is at position number 2. So but 2 in. Okay, and then this is chloro at position number 2. Okay, 1, 2, 3, 4. Yeah. So chloro is at position number 2 and 3. So it's supposed to be 2, 3, dichloro, but 2 in. But not only that, there is trans. Okay, this is the name for this. The same thing will apply here. Okay, you see 1, 2, 3, 4. Okay, so this is also but. Position number 2, put 2 in. And then at carbon number 2 and carbon number 3, there's chloro. So 2, 3, dichloro, put 2 in, but don't forget it's a cis isomer, cis 2, 3. So you see, same name. Same name. This is different. Why they are different? Because carbon-carbon double bond, okay, there is a restriction. There's restriction in rotation between carbon-carbon double bond. So because there is restriction in rotation, okay, therefore, okay, you can have cis and trans. Okay, you can have completely two different product. Yeah. So before that, yeah, it's already 125 minutes, 1 hour 25 minutes. So let's say we have addition polymerization. So if you have C double bond C, and then I have H let's say, for example, I have something like this. H, 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 HCl. Okay, so if I want to show addition polymer, yeah. So do remember, whenever you have carbon-carbon double bond, there is addition polymerization. So when you want to show, this is actually monomer, yeah. So if you want to show the polymer, what you need to do, you need to get ready for bonding. How do you get ready for bonding? You check carbon-carbon double bond. This is one group, this is one group. This is one group. This entire thing is one group. So you prepare for bonding. How do you prepare for bonding? Carbon, double bond, carbon. You put the hydrogen here. Okay, you prepare. Bring this thing below. And you put, okay, C3. Simplify. C3H7. You put this up, hydrogen. You put, get ready. Put Cl below. Get ready for the bonding. Next. Okay, the double bond is going to be broken. So reach out. Okay, reach out the hand. Okay, next, very simple. Copy this entire thing. Paste. Join them together. Okay, so this is going to be a polymer with 2 repeating units. Let's say paste again. Polymer with 3 repeating units. Paste again. Polymer with 4 repeating units. Is that clear, Nico? So this is going to be polymer, yeah? So there is going to be the double bond is going to be broken. So you have all the single bonds, okay? You get ready for bonding, that's it, yeah? So if, let's say they ask you, yeah, just polymer alone, yeah? The polymer alone, because this is the repeating unit. Okay, this is the repeating unit. So it's better to just write it like this: C3H7, ClH, put a bracket, put N, because why? This N, we do not know, yeah, how many times it will go. Okay, so if they say polymer, just put N. Okay, if they say this repeating unit, 4 repeating unit, 3 repeating unit, you just need to write and make sure that it doesn't end. Yeah, it doesn't end. That is going to be the arm is extended. Okay, so it should not end. So now let's say since just now we did this example, let's select one of the example. Okay, this one. Okay, 2,3-dichlorobutene. Okay, so let's say I want to actually write down or draw the polymer of 3 repeating units with this. Okay, 3 repeating units. Okay, what we need to do first? Okay, first, you draw this first. But2ene. But, how many carbon, Nicole? But, if you do not know, math is 1. Add 2. Prop 3. But 4. Pen 5. Hex 6. That's it in your syllabus. Yeah, up to 6. So if but, how many carbon?
4.
4. So you draw 1, 2, 3, 4. 2ene. It shows the position for the double bond. Position number 1, position number 2, position number 3. The double bond will come here. Position number 2. Okay. Okay, let me use the same ink. Okay, double bond will come here. Dichloro at position 2 and 3. This is 2. So 2, 3. Chloro. Done. Left with, make sure all the carbon have 4 bond. Okay, 4 bond here, 4 bond here, 4 bond. Okay. Now, Nicole, what should I do? If I want to draw the polymer. Carbon, carbon, identify the group. Identify the group. You can change this into CH3. You can change this into CH3. C, double bond C. You put the Cl, you put the Cl. I told you to prepare for bonding. So bring it up. Don't put it at the side. CH3. Bring it up. Put it so that you prepare for bonding. Next. Okay. Break the bond. Extend. Next. 3 repeating unit. Copy this. Copy. Paste. 2 repeating units now. Paste again. 3 repeating units. Can Nico? Not sure?
Why 3?
Why? Which one? Because the question is already 3 repeating units.
Oh.
Okay, it means the question is draw polymer of 3 showing 3 repeating units of monomer. Okay, if they say 4 repeating units, then you add another one. Okay?
Okay.
2 repeating units, then you erase. Okay, like 2 repeating units, so only 1 and 2. So this part you erase. And this is 2 repeating units. But if they just say polymer only, then you erase this part. Put the bracket. Put the end. Done. Can, Nicole?
Okay.
So I have done everything, yeah. So 1 hour, 30 minutes, okay. So in summary, yeah, so I'll quickly go through with you, okay. Alkane and alkene, they have, okay, similar reaction, which is the cracking and combustion. And then we learn under alkane, okay, there's free radical substitution, and then how to write the mechanism of the reaction. For alkene, okay, we learn for 3 reactions. One, okay, is going to be electrophilic addition. And then we learn about oxidation. And last, we learn about addition polymerization. Under electrophilic addition, okay, there's 4. Hydrogen, X2, HX, HOH. They have their own conditions, 140 degrees, nickel and platinum. Concentrated, room temperature, concentrated, room temperature. Concentrated H3PO4, phosphoric acid, 330 degrees Celsius, 6 megapascal. Okay, and then we also learn under here, Markovnikov rule. Markovnikov rule is, okay, I told you rich becomes richer, yeah. So in this case, okay, the tertiary carbocation is more stable compared to secondary, more stable than primary. Why? Because the alkyl group, okay, has inductive effect that will make the carbocation to become more stable. Yeah. So tertiary carbocation is more stable than secondary carbocation, and then secondary is more stable than primary carbocation. Under oxidation, okay, we learn, okay, 2 conditions. Okay, if it is cold and dilute KMnO4, you are going to get the carbon-carbon double bond. You will have the OH here. The double bond is broken, then you have another OH. If it is going to be hot, concentrated KMnO4, If you have carbon-carbon double bond, if you have H and H, then you break over there. You have carbon dioxide and water. If you have C, double bond C, okay, you have CH3 and then one H when you break. So C double bond O, you put O, and then CH3, the H over here, you must put O. Okay, this is only half of it, yeah. So if you have another carbon-carbon, and then you have CH3 and then CH3, if you break C double bond, you put the O, you put CH3, and then you put CH3, done. Okay, cannot put any more. Okay, that's oxidation. Under addition polymerization, just now I told, prepare for bonding. Okay, if you have H, CH3, Cl, and H, you prepare for bonding, you put Cc, CH3, you put the H here, you put the Cl, you put the H, then you put the double bond, you break, and then extend. Okay, then you copy. Based on the question, how many repeating unit? If they say 2 repeating unit, then you just put 2 repeating unit. If they say 3 repeating unit, then you put 3 repeating units. That's it. Is that okay, Nicole?
Yeah.
Okay, done, yeah? So hope you're ready for the exam. Okay, so you still need to study under the introduction to organic chemistry. Okay, revise more. I think I did the revision here. Okay, revise more on stereoisomerism, revise more on structural isomerism, and so on. Okay, any question you want to ask me, Nicole?
None so far.
Okay, so you take time to process all this, yeah, Nicole. Okay, I will put this video in YouTube later so the others can actually watch also. See you, Nicole.
Okay. Bye, sir.
Okay, see you, bye.